Hello, geometry family. Guess what? We're starting a new unit. We are going to start a unit that's Unit 7, Dilations and Similarity. And I really like the way that I have this unit organized, so fingers crossed you like it too and you learn something. So that's what we're going to do. So we are going to do a lesson today about dilations on a coordinate plane. If you're thinking, is that like when you get your eyes dilated at the eye doctor? It's exactly like that. All right. So dilations are actually a new form of transformation. So I want to do a quick review of the ones we did before. So a transformation is something that changes a shape in some way, changes it, turns it, moves it, flips it, something like that. A translation, that's the one where you slide an object, like you go up 3, right 4, something like that. One of the notations we use would be something like this: T2 negative 3, and that means you're going to go right 2 and down 3. Okay? So translations are a slide, rotations are a turn. Okay? And that's where you have a rotation around some kind of center of some kind of degree. So this would be a rotation of 90 degrees counterclockwise because it's positive about point C. And then reflections are a flip or a fold. Okay. And that's the lowercase r. And if you had like r, y axis, that means you reflect over the y axis. Okay. Dilations are a new one, and that's just a capital D with a subscript. So a dilation is going to be a shrink or a stretch. Okay. Which makes it dissimilar from the other ones because all of these are what are called rigid. If I could spell rigid, that would help. Rigid motions, which means that they preserve distance and angle measure. Both. They preserve both distance and angle measure. Dilations, though, given that they're a stretch or a shrink, distance is not preserved. Okay? Angle measure is, and you'll see that soon. So if we do a dilation, that's a shrink or a stretch. A dilation is a capital D with a subscript. This is your center of dilation. And K is what's called your scale factor. And sometimes you'll see that written as R as well, usually K, but sometimes R. So DCKXY means you're going to dilate the point XY centered at C with a scale factor of K. Now, this is not the best lesson for me to do on a video because I have this happy little think, notice, wonder here. But what I really want you to do for a second is look at this picture and realize, okay, ABC is this one right here. That's our pre-image or our original. And then A prime, B prime, C prime ended up out here. Okay, the new one, the image ended up out there. I'm telling you that this dilation is a dilation centered at the origin with a scale factor of C. So what happened? If I centered myself at the origin and did a scale factor of 3, A, which is negative 1, 2, became A prime, negative 3, 6. C is 2, 3, became 6, 9. 3, 1, became 9, 3. What happened? Well, if I dilated that by 3, and a 3 became a 9, and a 1 became a 3, that's right. Hopefully you're thinking it. What happens to the coordinates based on the scale factor? The coordinates are multiplied by the scale factor. Let's test that theory on the second one. In this second one, I have a dilation centered at the origin of a half. And this says ABC and A prime, B prime, C prime, and I'm realizing that that is a boo-boo. This should say triangle EFD, or EFG, pardon me. And that should say E prime, F prime, G prime. My apologies there. So that means I started with this one, and then it became that one. 6, negative 2 became 3, negative 1. Did I multiply 6 and 2 by a half? Yeah, Yeah, I did. 8 negative 4 became 4 negative 2. 8 times a half is 4. Negative 4 times a half is negative 2. Yeah, we multiplied the coordinates by the scale factor. Now, what happens to the shape based on the scale factor? Well, when I had a scale factor of 3, it got bigger. When I had a scale factor of a half, it got smaller. Okay, so a scale factor greater than 1 makes the shape bigger, and a scale factor of a fraction less than 1, so like 3/4, 1/2, okay, is going to make it smaller. Okay, so let's do it. When you do a dilation centered at the origin, you multiply by a scale factor. Okay, so that's the rule that you need to know. So a dilation centered at O, okay, 0, 0 of K. By the way, we sometimes call the origin O. So if I do a dilation centered at the origin with a scale factor of K, then XY, whoa, becomes kx, ky. You multiply by the scale factor. So what are the coordinates of the image of 2, negative 4 under the dilation of origin 2? So if I dilate that from the origin with a scale factor of 2, I literally just multiply by 2. 4, negative 8. Don't make it hard for yourself. What's the dilation that mapped negative 4, 6 onto negative 16, 24? Well, since I centered at the origin, I multiplied by the scale factor. So what did I multiply by? I multiplied by 4. AB is 5 units long. Then I dilate it by a factor of 2. What's its new length? Well, when you multiply by a scale factor, the length gets multiplied by the scale factor. So 5 is dilated by a factor of 2, 10. Area does not get multiplied by the scale factor. Something else happens. So quick aside there. Length gets multiplied by the scale factor. Area does something else. Then find the scale factor that mapped negative 4, 6 onto 10, negative 15. Ooh, I don't know what number. Negative 4 times what is 10? I don't know. Let's figure it out. Negative 4 got multiplied by k and became 10. Let's just solve for k. So I'm going to divide by negative 4. And 10 divided by negative 4 is going to be negative 2.5. Mrs. Vibber, can scale factors be negative? They absolutely can be negative. All right. As a matter of fact, let's test out what happens when your scale factor is negative. So dilate BCD, with B, C, and D right there, from the origin with a scale factor of negative 2. Well, if I dilate from the origin, I multiply the points by the scale factor. So negative 2 times negative 3, 0 is going to be 6, 0. Negative 2 times negative 2, 4 is become positive 4, negative 8. And then 1, 3 times negative 2 is negative 2, negative 6. All right. So B became 6, 0. So there's B prime. This became 4, negative 8. There's C prime. And D became negative 2, negative 6. There's D prime. Okay. Is the image larger or smaller than the pre-image? Well, the new one I drew is definitely larger. Compare the slopes of CD and C prime, D prime. Okay, so the slope of CD is rise over run. So from C to D, I went down 1, right 3. And then the slope of C prime, D prime, let's see, is going to be change of Y over change of X. So my slope down here is down 2, right 6. So that's negative a third. Hey, what does it mean if slopes are the same? That means that the image and the pre-image are parallel. When you do a dilation, your image is parallel to your pre-image. Okay, or at least the parts of your image are parallel to the parts of your pre-image. Cool. How do you think the negative scale factor affected the image? Well, it definitely got bigger. My -2 made it bigger. But you know what happened with the -2? If we go back for a second, when I dilated from the origin with a scale factor of 3, what happened is that these things got pushed further away from the origin. So, like this length right here, the one that's black, compared to this length right here, that blue line I just drew is 3 times longer than the black line. Okay, or 3 times as long as the black line, I should say. When I come over here, O to B is 3, O to B prime is 6, but it goes in the other direction. So how does the negative scale factor affect the image? It rotates it 180 degrees. It turns it. So if you think about this blue one and you were to turn it upside down and then stretch it out, that's where that black one came from. Okay. All right. Now, what happens when I dilate somewhere other than the origin? All right. Well, let's see. This is another one where in class I'd have you think about it. Describe A prime B prime after a dilation from point C with a scale factor of 2. Okay, well, this blue one became this green one. So what happened here? Well, let's see. This blue one is like 2 diagonals long, and this green one is 4 diagonals long. So it's definitely twice as long. So changing the center doesn't seem to matter. Let's see. From C to A, I go right 2 up to, right 1 up 2. So from C to A, I go right 1 up 2. From C to A prime, I go right 2 up 4. So I've doubled the distance. Okay, so AC times 2 becomes A prime C. So that's there. What happens to the coordinates? 4, 2 became 7, 2? Yeah, the coordinates, they don't have a rule. I definitely don't multiply by the scale factor to get my new coordinates. So what happens from a center other than the origin? Well, what happens is you just push it further away. All right. So if I wanted to plot D prime E prime after a dilation from F of a scale factor 3, what I'm going to do is say, all right, from F to D, I go right 1 up 2. If I dilate that by 3, instead of going right 1 up 2, God, I'm not saying the right thing today, am I? Pardon me. I went right 1 up 2, 1, 2. If I dilate those numbers by 3, I have to go right 3 up 6. 1, 2, 3, 4, 5, 6. So this is now D prime, and that's the point -1, 6. All right. Now let's do E. So to get to E, I go left 1, up 1. So I'm going to go left 3, up 3. There's E prime, and that's -7, 3. And if I connect D prime, E prime, that looks 3 times bigger, and they do look parallel, like I saw before. So when you dilate from the origin, you want to multiply your coordinates by the scale factor. If you dilate from something other than the origin, you just have to count it out and go 3 times as far away. All right, so let's tie this in a bow. Complete the following composition of dilations from BCD with those coordinates. Dilate it by a scale factor of 1/2. Remember, this comes first. And then dilate it by a scale factor of 4. Okay, well, My first dilation by a half is going to cut each of these coordinates in half. So C prime would be 1, 1. B prime, there we go, would be 1, 4. And D prime would be 3, 1. All right, so 1, 1, 1, 4, 3, 1. Okay, there's my little baby triangle. And then when I dilate that new one, because I start from this fresh green one, and dilate that by 4, C double prime is going to be 4 times the coordinates, because I'm dilating from the origin. So that'd be 4, 16, and D double prime is going to be 12, 4. And so now I'm going to make that one blue. 4, 4, 4, 16, 12, 4. There's my new one. What single dilation can be used? Well, what did I do to 2, 2 to get 4, 4? I multiplied by 2. What did I do to 2, 8 to get 4, 16? I multiplied by 2. What did I do to 6, 2 to get 12, 4? I multiplied by 2, Mrs. Bibber. You got it. If you do multiple dilations in a row from the same center, the single dilation is keep your center, multiply the two scale factors together. A half times 4 is 2. So if you do multiple dilations from the same center, you can multiply the scale factors together. Okay? Okay. Lesson summary, and then I'm done. The rule for dilating points by a scale factor with the center at the origin, you just multiply the components. So you just multiply by the scale factor. When a figure is dilated by a positive scale factor of k, the lengths of the figure are multiplied by k. So if I dilate from center C with a scale factor of 3 and AB becomes A prime B prime, then if my original length is 4 and I scale factored it by 3, I get a length of 12. Long story short, when you multiply by a scale factor, that's what happens to the lengths. If you multiply by negative scale factor, you just ignore the negative for the lengths. When using a negative scale factor, okay, the image is rotated 180 degrees, okay? But the lengths and the coordinates do get multiplied by that scale factor. You just ignore the negative. To find points on a coordinate grid, when the dilation center is not the origin, you just count it out. And you basically push the image k times away from the center. And last but not least, when you complete a composition of dilations, the final image of scale factor is the product of the scale factors used. Ta-da! That's it. That's all I got. So hopefully this made some sense. You are going to go through later and you are going to do some homework that goes with this, and I hope that that makes sense too. I hope everybody is currently having a good day and continues to do so. Bye.